Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today's going to be kind of an interesting video, I hope. I hope you like this. What I'm going to do is I'm going to show you this remote cabin. It's my buddy's cabin up in the mountains of Utah here. And like I said, it's remote. It's on a dirt road. It takes a few miles to get out there, okay? More than a few miles. So it's very difficult to get to in the wintertime unless you have snow machines. He goes there in the springtime after the snow is dropped down and level. He has family up there, but he needs to keep an eye on the cabin with these cameras and Wi-Fi and the satellite link he has. So to make sure that a tree doesn't fall, something doesn't happen to the cabin, and that he comes in there with a big surprise and a bunch of damage, right? So it's important to have electricity even in the wintertime. So obviously he's off-grid because it's remote. So he relies on electricity from solar panels or from his generator. But if he's not there, he can't start the generator. So in the wintertime, it's all solar power, okay? So, yeah, let's just jump in this video. Okay, so what I'm going to show you is a shed behind the cabin, okay? It's kind of a tech shed. It's got all the electronics, it's got the generator and all that, and so we're going to show you the batteries, okay? So, and it's really hot, and we got those flies that are just attacking us. The little deer flies or horse flies, whatever they are, just little guys, really aggressive, and they'll just eat you until you get them off you. But yeah, lots of them too. You can see the chunks of my legs in some of the videos that they've been chewing on me. So let's show you the shed and the batteries, okay? All right, guys, here's the shed. Here's the foam that we're going to use for insulation. And let me show you the system. Here's our batteries, okay? The two big 24s. We got a couple smaller ones over here. And there is the box. We got our breaker panel, power switch, our inverter system, and power conversion is the auto switching network, disconnect, and our solar boost. And then over here we have a generator disconnect, which behind me is the generator. So here's the generator. By the way, it has a lead acid battery too. So there is the setup in here. Window for some cooling. And here's looking outside at the back of the cabin. All right, let me show you the batteries. There's half of them. Look how clean after we cleaned them up. Took 2 or 3 hours to do this. I think it was about 3 hours. Clean them all up. I'll open up the other lid. And there we go. Look at that, guys. A lot of batteries. So 4 of those guys are making 24 volts. Then these 2 guys, there's another 4, and here's 4. Okay guys, so you see the batteries, right? And I'm going to show you how they're made up in that box, but I'm showing you this picture right here. A lot of information here, but let's just go through it quick. There's 3 banks of a 24 volt battery, okay, if you look at it that way. So 3 24 volt batteries in parallel. Well, each one of those 24 volt batteries is really 4 6 volt batteries, okay? So I'm showing the 4 6 volt batteries, they're in series, okay, so they add up to 24 volts. There's 370 amp hour. Now, when they're in series, you only get, the current 370 amp hour. Now, if one battery loses its capability, then in that series lineup, you're limited to whatever the weakest battery is, okay? So, yeah, so there you go. Now, here's the thing with lead acid batteries. I'm showing 24 volt, 370 amp hour. And then over to the right, it's, or down below, add them all up, it's 1110 amp hour total. That's best case. There's a sweet spot with lead acid. And it's, in this case, I think it's 20 amps. So it starts off low as far as amp hours and goes up to 370 amp hours, and then it drops a bit down again, okay? So let's say, I think it's around 5 amp hours, kind of the worst case, or I think it's the worst case on this battery, is 190 amp hour, okay? And the reason I was choosing that one, because 3 batteries in parallel, you get 5, 10, 15 amps. So if each one's given 5 amps, 15 amps. And what I've seen on his box is around 20. So I took the 5 amp one because that was the closest one that I saw on their data sheet. But 190 amp hour. So in that case, it's almost half of the optimal, you know, the peak. So that's the way lead acids work. Lithiums don't work that way. You get so many amp hours within almost a full range of the current capable. Okay, so that's kind of a cool thing about lithium. Also, lead acid, over the years since these batteries were installed, they've been getting weaker and weaker and weaker, right? With lithium, they really stay really good until the end, and then they cave in. The other thing with lithium is, like, you know, these technically should last 10 years, right? But really, in the application, they'll last much longer, the lithium batteries will. So you're going to get really good usage for a long period of time. All right, so right down here, what I'm showing is 110 amp hour. If you go 3 times 25 volts times the 370, you get 28.6 kilowatt hours. That's a lot. So these batteries, the optimal current usage, you get a lot of kilowatt hours. Now, down around the 5 amp, where we're probably closer to, especially in the winter time, it's only like, you know, 14.7 kilowatt hours. So it's going to be somewhere in that range, probably closer to the 15 kilowatt hours. Still, that's pretty good. That's a lot of batteries too. That's, you know, we got 12 batteries, 12 lead acid batteries. Okay, so let's just go over that system real fast, okay? Now, we didn't use this many 300 amp hour batteries. I'm showing 6. So if we did 3 24 volt batteries, like we're replacing, like if we replace 1 for 1, so 300 amp hour, what these things are rated for, which is great, because whether it's 5 amps or 20 amps or more, you're going to get the 300 amp hour. So you're not going to be like the other one. So you're down at the bottom, I added up and it says 23 kilowatt hours. So you're going to get a lot more kilowatt hours off lithium batteries. And it's only going to take 6 12 volts instead of 12 6 volt batteries. Okay, so simpler system to install. Now, this is not the one we did, but if you're going to do a 1 for 1, I just want to show you the comparison. Okay, so you actually get more out of half the batteries, similar amp hours. But I mean, the lead acid only beats it at the 20 amp at the peak, the optimal current usage, where the LiFePO4 batteries are going to beat it across the board, right, in actual usage. So now what I want to show you is the cost. What's the cost difference? Well, you might be surprised that the lithium iron phosphate is actually lower cost. When you're buying 6 of them, you get a better price on them, okay? So the Grener Power, if you go look at their thing, if you're buying 1 battery, it's closer to $700 or something like that. There's a discount on that too, so it's like $630 or something like that. But when you're buying 6, it's like $609, okay? And there's a big sale going on, so you might even be able to get them cheaper than that. But still, you're only paying around $3,600, say $3,700, round it up. So $3,700 compared to, say, $5,400 for all the lead acids. Yeah, I was surprised to see those, each one of those 6 volt batteries cost $446, and 12 of them, you know, is expensive, right? So you actually save like about 32%. So with the lithium iron phosphates, and with the cells, I think you can even do better than that even. All right, so weight. Look at this. Those lead acid batteries, when I went to pull them out of the box, I thought they're stuck to the bottom. I thought they're corroded or something. I didn't realize how deep they were. It's kind of funny because I guess I should have saw the side of the box and been able to tell that. But since you could only see the tops of the batteries, it just didn't strike me until I tried to pull one out. It was difficult. The first one was the hardest one, and the other ones I could get a grip on the bottom, you know, but I thought, I was guessing these things have to be at least 80 pounds. They were heavy. Turns out they're 111 pounds. That's just nuts. So, and when you get 12 of them, you actually have 1,300 pounds, over 1,300 pounds, 1,332 or 604 kilograms. So really heavy. Now, the lithiums obviously are lighter. They're only, but these are big 300 amp hour ones, 62.48 pounds. So with 6 of them, the weight's only like 375. So that's a savings of like 72% weight. So what that means is, besides having to move them around, carry them from, go buy them and move them around, all that, the shipping costs. Oh yeah, we didn't even take into account shipping costs, but the cost of the framework, whatever you put these batteries on, has to be strong to hold 1,300 pounds, right? In comparison to, say, 375 pounds. So you got to take that into account too, the structure of your bench or whatever that you put them on the shelf. All right, so now look at the volume. Now that's the size, right? You can see the length, width, and height, and it came out to about 9.4 cubic foot for the lead acid. So yeah, almost 10 cubic feet. And the lithiums were almost 6 cubic feet. So about 40%, 39% smaller, right? So again, when you're building that structure to hold the batteries, it doesn't need to be as big either. Now, here's the thing is, in this case, he had a box built, and the box was built specifically for that size of battery. So that's why we didn't use a bunch of 300 amp hours, because the box just didn't want to fit. We didn't want to build a new box. So I'm going to show you the system we actually put in, okay? Okay, guys, so this is the system we actually put in. We used 2 of the 300 amp hours, only 2, to get a 24 volt battery, and then we put it in parallel to another 24 volt battery, but that one is 100 amp hour. So we used 2 100 amp hour batteries, okay? So that's how we did this, and the 100 amp hours were Golden-Mate batteries, and the 300 amp hours is Grener power, okay? Please use the links down below, appreciate that. But anyway, so in this case, it was a smaller system, but what our thought was is those lead acid batteries were nowhere near the optimal for the last couple of years he's owned the cabin, or 2 or 3 years, whatever it is. He hasn't been getting that much power. The red light was actually blinking on the panel. So we think that, 6,400 watt hours based on seeing 20 amps being taken out, I think it's going to suit him, at least for a while. If it doesn't, the next year, we can, or even before winter, we can put more in, okay? But that's what we ended up going with. So the cost of that system is even lower, right? Because we're only buying 2 of those batteries, and in this case, they're $623 each, for buying 2. A little bit better price than buying 1, but not as good a price as buying the 6, okay? And then we had 2 of the Golden-Mates were $240, okay? So the price ends up being just over $1,700, $1,726, compared to the $5,300 if he had tried to replace it with the same lead acids. And then there's a maintenance and all that. And from that video, when you guys looked at the batteries, you can see that red stuff. We spent 4 hours, I think it was, cleaning those batteries I thought it was less time. I thought it was 2 or 3 hours, but he's like, oh no, we were in there for like 3 to closer to 4 hours, brushing them, cleaning the corrosion off, cleaning them all up, and then putting it back in. So, and yeah, anyway, and we took off 1 cable at a time so we didn't get things mixed up. We disconnected power and then we did all that stuff. So yeah, there you go, guys. Much lower cost system, and chances are this one's gonna last, so we'll see. And even though it's a smaller system, guys, and they're gonna work this way for 10 plus years at least, then from the studies, they show that you even get more cycles than what they brag about, which is kind of rare in marketing, right? Usually marketing is blowing out numbers, but in case of lithium iron phosphates, you're actually getting more time, more cycles. And the way he uses it, when he goes to the cabin, he's not there all the time, right? He's got family around there that watches his cabin, helps him watch it. He's got cameras set up, so he wants to keep those guys running, the cameras running all the time, the security system, and all that. So yeah, we think that the calculations that this battery system will work, but we'll see. Okay, all right, let's jump back in the video. Right now we're charged at 25.2 volts. There's the solar panels over there, and sun's right behind that cloud. So we'll see what we get. These 4 batteries are 6 volts each, so 24 volts. So they're connected in series. Okay, plus minus. And then over here is the plus, the minus. So it's 4 of them on top of each other, right, in series. And then these 2 long cables come over here, connected the end of these, this series chain, same as the one over there. So we have 12 volts there, or 24 volts there, 24 volts here. Then those 2 long cables come over here, and we have another 24 volts. So we have 3 24-volt batteries. That's how it's done. So we're going to start by disconnecting one of these ends to disconnect it from the chain, and then we're going to disconnect each one of these individually, and then do the same thing here. Disconnect this from that series, and remove them all, and then finally disconnect the last series. 1 battery, 1 post.
Where should we put these bolts?
Yeah.
Is the floor okay?
Yeah, I think the floor is a good place because they're going to fall anyway.
Right. I was going to say, so as long as we don't kick them.
So, all right, guys. Mr. Lee here and I spent 2-3 hours cleaning these posts so nice and neat, and now the bolts are going to come off. Cable's going to come off. We took each one off, cleaned it, scoured it. Yeah, that's why it's coming off so easy. All right, guys, check out this battery. It is a beast. These things are heavy, heavy, heavy. They're really tall batteries. Super tall, and they're kind of bulging, if you can tell. Just a little bit of a bulge going on. That one looks bulging a little bit more.
There we go.
Whew, there we go. All right, wheelbarrow to the rescue. All right, guys. Wheelbarrow saved our lives. These things are beasts. All right, guys, we're 26.7 volts. We got a flashing. It was solid. And it's flashing, so we're in acceptance mode. We went from bulk to acceptance, then it'll flash faster. We're in float, and then real fast for equalize. And that's because we only have 4 batteries left. 124-volt bank. That bank's gone. This bank's almost gone. Whew. And that's going to leave us space for all that insulation that we're going to use to keep these things warm, hopefully through the winter. So that's the idea. We were afraid of the height here, but now that we've realized these batteries are so tall, we have room for insulation up here, bottom sides. All right, guys. So one thing lithiums don't like is they don't like to be charged in cold weather. I think it's under minus 20 C. So now we're remote up in the mountains, get lots of snow. So we're going to put a bunch of insulation in the box and hoping the batteries keep that warm. We're going to check that, and probably what we'll do is put some heat blankets in the box before winter time, okay? And with all that insulation, they'll get automatically turned on, and then they'll turn off, and I don't think they're going to be on very much. One trick with lithium iron phosphates, by the way, is you can turn on a load. Like, let's say you turn on a heater in the house, and that load starts to pull current. The security systems and that kind of stuff, they might not pull enough current to keep the batteries warm, but you pull a little bit more current, the batteries will warm up. And maybe even the security camera might keep them just warm enough to keep the temperatures up. So that's one of those things we're going to have to look into before winter comes. But our plan is to put a couple blankets in there to keep those batteries warm for the winter. All right, so that's the cold temp solution. Let me know in the comments down below what you guys recommend using, okay? All right, guys, we needed a screwdriver and stuff to loosen that one because of the corrosion. See that? Okay, guys, we got the Grener power, and these are the 300 amp hours, the big beast. And the bad thing is they didn't really, pack it very well. Very thin piece here, not double boxed. And these are big batteries, but I did, here, let's take them out. Oh, so much lighter than those other batteries. Take off the seal, but yeah, nice handles on them. Here's our terminals. 12.8, 300 amp hour. And as far as boxing goes, pretty chintzy. And here is our bolts. All right. All right, guys, here's the documentation. Pretty nice. Okay. And service card. All right, very nice looking batteries. Here's the specs, so on. Okay. All right, guys, we got the first 2 layers of 1.5 inch insulation. So we have 3 inches of insulation on the bottom. We've got another thick piece. We're going to put another 1.5 on the back. And then we're going to use these 1 inch pieces on the ends and over here. If we have enough of the thicker one, we'll use it on the ends, but we probably don't. So anyway, we might double the ends up. I think we have room to double the ends. We won't use all this space. Guys, we have another battery, Golden Mate. It's LiFePO 12.8, 100 amp hour. So it's double boxed. And so it's packaged really well. Yeah, there we go, Golden Mate. So there we go. And whoa, God, this seemed like a static theme. It couldn't have been. Had to be me just hitting the cap. There are little bolts in here. I think thought there might be hardware in here. I don't see it. So let's see. There we go. It's right there. So we got these little plastic protecting caps. Okay, guys, so you can see there's some big batteries, the 2 300 amp hour batteries, okay? They're both 12 volts, so 2 of them in series gives us 24 volts. And then we take that 24 volts and put it in parallel with the other 24 volt, which is made up of the 2 12 volt 100 amp hours. So we get 100 amp hour on that chain, 300 on that. So we get 400 amp hour total. That's the makeup of the batteries we decided to go with. All right, guys, so look at the insulation going on here. We got a couple layers here, so there's a couple inches there. There's 3 inches there with another 1.5 inches. And we're going to put some on the ends here, some on the ends here. And the reason we didn't slide the cables or the batteries all the way over here is because our cables to those are long enough to reach here, and then that gives us space to put insulation. So we'll tie plus minus here, so we'll have 24 volts here. We'll tie those together, and we'll have 24 volts here. And then we'll tie these 2 24 volt systems to this guy. You gotta have a beer break, so let's do that. All right, man, look at that. You get the right beer, you'll do anything. Thanks, Lee. All right, guys, so I got one of these. So we have a wire right here coming from the charger, okay? And then we have a big wire coming up through here, up through the inverter. So, and then we have the wire coming from the battery. So first we're just gonna hook up these 2. So I've got them temporarily hooked up like this, and had to clean the cables that were connected to the batteries, these 2, with a wire brush and a screwdriver to get them nice and clean. Yeah, so we won't have that problem anymore now that we got rid of the lead acid. But now I'm going to take the red one and this red one, same thing. The red one goes from the charger. The big red one comes from this guy. These cables back here drop down around there, come around here. So I'm going to tie those together to this guy with another long cable. These are 2-aught cables. Actually, these are 2-aught cables. This one, I think it's, let me look what size. All right, guys, so the placement in the box. We put the 300 amp hours, they're going to have more current up closer, okay? Now, the cables that we're going to use are big cables. The big ones are, I think, 4-aught, and the smaller ones are 2-aught. So big old beefy cables with a lot of fine wires in them. So I believe they're for welding, so they're flexible. But the first set is the length of them puts the big batteries kind of more towards middle. And I put the terminals towards each other so the current from each battery has the same distance to the load. So that's kind of why they're facing that way. And it makes it convenient because then the short cable can tie them together. So they're just stacked on top, right? You got, 12 volt battery and 12 volt battery makes 24 volt battery, right? So the plus of this one ties to the minus of the top one. So you get the plus on the top and the minus down here, 24 volts. Okay, so that's how they were done. And then the smaller ones have less current coming out of them, so it's okay to have them a little further away. Still, those cables are so huge, they have very little resistance. They're not going to heat up, and everything's going to be fine. So yeah, that's why we kind of placed them where we did. And then it leaves room on the edges to put lots of that foam, so it's going to keep those things insulated. Okay. All right, so the big cable is actually a 4-aught Xylene cable, 105C, 600 volt welding cable, made in USA. So that's the big long cable. And the shorter cables that we took off that I'm using for here and here, they're 2-watt. Okay, same kind of specs other than they're 2-watt. All right, so we have a 24 volt battery that's 300 amp hour, 24 volt that's 100 amp hour, and I've got them all wired up, and I'm gonna put them in parallel now. But before I do that and just bolt it down and hope everything's fine, I want to make sure they're balanced so they're pretty close to each other. If they're within a certain percentage, you're gonna get the one that's charged higher charging the other one, so it brings them to equilibrium, right? And so, you know, if the smaller batteries are the higher voltage, they're going to try to dump into a low impedance big battery. And so I'm kind of hoping it works out that the bigger batteries are charged higher. I have a charger that if I need to balance them, I'll do that, but I want to check it. And then I'm going to have a current meter so I can measure how much current's rushing in and all that kind of stuff. And yeah, so let's go ahead and jump in and do that part.
Live.
So, okay guys, we're going to check the batteries. We have the wiring almost done. So we're going to see if we got 24 volts here, 26.3. Now we want to see if the batteries are balanced so that we don't have arcs and sparks. So, okay, 26.6. So it's only 0.3 higher. So what we're going to do is we got this cable. This is the last cable we have to touch. It's not tight there, but I'm going to touch it down here. We're going to put this in current mode. See, turn on that backlight. There we go. So I'm going to put this on, and then we'll see if it gets hot when I touch this. It shouldn't. It's close in voltage, but let's just test. Okay, it's only drawn a little over an amp, so that's not bad. So we're going to go ahead and connect them. All right. Whew. All right, guys. We got these 3 wires put together too. So now it's all put together. Look at that. Isn't it? Check it out. We got big old 300 amp hour batteries from Grener Power. Awesome. And we also have some awesome batteries from Multimeter. So, and they work together. So we have 24 volts here. We have 24 volts with these. 24 volts with 300 amp hours and 24 volts with 100 amp hours. And then look at this. We're charging 11 amps. There we go, charging 11 amps there. And then up here it says 10.1. It says 11 here. And then if we're putting out any current, that's to the inverter. There we go, 1.2, 1 amp to the inverter. There's really nothing going on in the house except for some fans. So, awesome meter, Yoki. I gotta show you the Bluetooth on this. But yeah, once we did that, we hit the battery connect, then we turned on the power here to the house, and then we did inverter on. That was it. All right, guys, we got 26.6 volts coming in. It's bulk charging. If we go to the panel current, 9 amps. Output charge current, 9.9. Looking good. 26.6. And you can see this kind of an overcast day. The sun's right there. Overcast. All right, guys, we got 26.5 volts, 20 amps on a good sunny day. There's the solar panels. All right, guys, I want to give 2 big thumbs up for Grener Power, or Grener Power, however they pronounce that, and 2 big thumbs up to Multimeter. Really appreciate those 2 companies for giving us some good discounts on this stuff. They've given me some free batteries in the past, so I've got like 1 of each of their batteries around here, and I just got a new one from, I think it was Multimeter, and it's really cool looking battery. I got to show you guys that one. It's crazy looking. But anyway, 2 big thumbs up to both those companies for supporting this video, giving us good discounts for the batteries. That was a lot of help. And yeah, some channels, they get batteries given to them to do projects like that. But in this case, I'm not that big of a channel, especially in doing this kind of stuff. And so I really feel that they gave some good discounts, and that was really nice of them. And they've got some great sales going on. The prices are really good on these. It's kind of crazy how good the prices are on these grade A lithium iron phosphate batteries. But yeah, they seem top notch. So really appreciate that. And I appreciate you guys giving a like to the video if you watched this far, if you like it, and subscribing to the channel. That's a big help. And using the links down below, that's a huge help. Yeah, all that stuff. Liking the video, sharing it, and subscribing, right? That's what everybody says, and that's because it's important. All right, guys, really appreciate it. I got some audio videos I got to jump into, and I've got, so I've done a lot of work on in the background on some of this other stuff. Haven't posted a lot of videos lately. Sorry about that. I just got, I went out of town to do this install, and then I got back, and God, I've had many things going on. And yeah, I wish this channel paid more bills, because, it'd be really nice. But yeah, it's changed a lot. So yeah, I'm probably breaking even on this channel. And so I had to do some things to work out some other deals. So anyway, I might do some more contracting work. But I'm going to try to figure out how to do more videos and keep them coming as well. All right. So appreciate you guys hanging in there with me. I want to start doing some live videos as well. So just got to figure that out. Thanks for watching, guys, and we'll see you next time.